Hello everyone, welcome to the next session of ANSYS Workbench tutorials. In this session, we are going to continue with the 1D beam analysis. We are going to start with the continuous beam analysis. In the previous classes, we were discussing about a single line beam. Here we are going to discuss about multiple line beams which are placed one beside the other, making it a continuous beam. We will be plotting the shear force and the bending moment diagram for the loading on such type of continuous beams. This is the first question that we are going to solve. I have already solved the numerical using theoretical method, that is by the method of strength of materials, and uploaded the same. You can check the video and get the solution for it to tally the answers with the answers obtained by using ANSYS. Draw SFD and BMD for the cantilever shown in figure below. Here the cantilever is AD. One end A is fixed and at point B, C and D, I can see that there is some loading applied. The length is given as 1 meter, 1 meter and 2 meter for each section of the beam. So rather than drawing an entire line and trying to figure out these positions and apply the load, we are going to segregate and draw each part of the beam like AB, BC and CD. Also, I would like to mention that I am using 1D type of beam analysis because if you are using 2D and 3D type of beam analysis in ANSYS, it will not be possible to get the solution of SFD and BMD. So we need to use 1D type of analysis for it. So let's get started. I will go to static structural and double click on it. I'll rename it as example 1 SFBM. I'll go to geometry, right click, new design modular geometry. I'll go to XY plane, look at. Now if you see the diagram, the units are in meter. So I will choose the unit as meter, which is anyways by default. I'll go to sketching, line. I'll draw the first line, A to B portion of the beam. I will give it dimension of 1 meter. If you want to adjust this H1 that is written here, you can use the move option. Next, again I'll go to draw line. I'll draw the BC portion of the beam and I'll draw the CD portion of the beam. And then I'll give both of them dimensions. H2 and H3 both will be 1 meter. Next I'll go to concept, lines from sketches. I will have to choose the sketch. So I'll come here and choose sketch 1, apply, generate. Next I need to give it a cross section. You can see line body requires a cross section. So I'll go to concept, cross section, rectangular. Now since we are solving for SFD BMD on the beam, cross sectional dimension is not going to be very important. So I'll give it a rough dimension of 0.05 and 0.05. I'll go to line body, cross section, rectangle 1. Now if I want to see the cross section, I'll go to view, cross section, solids. I can clearly see my cross section here. So this ends the geometry part. Next I'll go to model and double click on it. Now I'll go to mesh. I'll change sizing to fine, update. I can clearly see my 3D body. So this is my orientation. Now I'll go to static structural. I can see the vertices on the beam because the show vertices is what I have clicked on. I want to apply fixed on this end A. You can see from the diagram end A is fixed. So I will choose point. Here I will insert fixed support. At point B there is a load of 10 kilonewton downwards. At point C 20 kilonewton upwards, and at point D again 10 kilonewton downwards is what I have to apply. At B, insert force. I'll change vector to component. Now I can observe that this is the y direction in which I have to apply the load. So I'll write here minus 10,000. At point C, I'll insert a force. It is in the upward direction. So I'll write here just 20,000. And at point D, again I'll have to apply a force minus 10,000. Okay, there's one thing that needs to be changed, that this length was 2 meters. So I can just go back to my geometry. I'll go to the sketch. I'll change H3 to 2 meters and generate. Next I'll go to model and double click on it. It is asking if I want to read the upstream data, which means whatever changes I have made in the geometry, if I want to incorporate in the model, I'll say yes. And everything has been incorporated. The mesh needs to be regenerated, so I'll click on update. Now I'll go to solution because I have applied all the boundary conditions, so I'll click on solve. Now I'll go to solution, right click, insert, deformation, directional. Since I've applied the load in the y direction, I want to see the deformation also in the y direction. I'll insert probe, force reaction. I want to see the force reaction at the fixed end. I also want to see the moment reaction at the fixed end. I want to see the beam tool results, that is the stresses, minimum and maximum combined stresses. If you recollect, we have already done these analysis, so I want to see those results. And fill and final, I would want to see the result, that is of shear moment diagram. Now it is asking me for a path, so I'll go to model. You can see here construction geometry. I'll choose path. Instead of path type as 2 points, I will change it to edge. I will select edge option from here. I will click on the first edge, then press Ctrl button and then select these two. And that's my geometry. Now the path has been created. If you want, you can rename the path over here. I'll leave it to path itself. I'll go to total shear moment diagram and this is the path generated. I'll go to solution, right click, evaluate all results, or you can directly click on solve at the top. So you can see here, this is the directional deformation of the body. I'll click on animation. This shows how the body is going to deform by the application of the loading that we have done. Next, I can see the force reaction on the beam. I want to see the force reaction in the y direction. So here you can see it is 4.8 into 10 raised to minus 6, which means it is very small, and the answer obtained by theory also is 0, which means this value, which can be approximated to 0, is equal to the answer that I obtained by theoretical method. Next, I'll go for the moment reaction at this end A. You can see over here the value is given. This is in Newton mm. I can change the units to meter. So this gives me the value. This value is 10,000 Newton meter. That is 10 kilonewton meter, and that's the correct answer as per the solution. Here you can see the minimum and the maximum combined stresses on the beam. You can animate and check the result. And last, we want to see the shear force and bending moment diagram that's obtained here just by clicking on it. The first graph is of total shear force. You can check the shear force here, and the solution that we have obtained by theory. I would like to add the solutions that you obtain by ANSYS and by theoretical method will have a little difference in the direction of your graph, that is positive and negative value. The reason being the assumption of direction. If you remember, while explaining theory, I have told you that when I say the force is moving in the upward direction and I assume it as positive, it's a pure assumption, it's a sign convention. It is to each his own. Any person can very clearly say that a force going in downward direction is positive and a force going in upward direction is negative. So that's his assumption. So accordingly, in the software also, you will see that your graph's direction may not match with your solution, but yes, the values is what you can definitely check from here. So I can see that at 1 meter, this value is approximately 0 that we have obtained, and in the diagram also you can see at 1 meter it is approximately 0, and then I can see it is 10 kilonewton here and here in both the sides. So you can check it is 10,000 Newton. That's what is shown here. Now when you go for the bending moment diagram, initially you will see that the value is from 0 to 10,000. You can check here, it is 0 to 10,000 or 10 kilonewton meter, and then you can see a graph like this at point C, that is 2 meters from point A. You can see that the bending moment is maximum, that is of 20 kilonewton meter. So here also you can see that this is the point C where your value is 20 kilonewton meter or 20,000 Newton meter. You can see it's written here at 2 meters. So the solution which I have obtained by theory has matched the solution which I have obtained by ANSYS. So I can say that my solutions are correct. With this, I end the session. I hope you have understood this numerical. If you have any doubts, please write to me in the comment section. See you in the next session. Thank you.